morning, group. So for the day 2 notes, we're doing the line of best fit, and this may be something that you've already seen before. We're just going to review it, and we may add in some new things. So the first thing you're going to do is go ahead and make a scatter plot of the data. If you look here, you basically have x and y coordinates. So your x coordinate there would be 26. Your y coordinate would be 49. Just do it the best that you can. If you look down here, it looks like we're going by 2s. So right there would be pretty good. So they're not going to be perfect, but do your best. Okay, so once you have that data ready to go, we can kind of proceed through the questions here. So if you look at part B, it says, draw a line of best fit. So your line of best fit, ideally you would like to have the same number of points on the left side that you have on the right side. So if I kind of look at my line of best fit, maybe something like that. Okay, that one's not perfect, but you know, something similar to that. Okay, then it says in part C, the equation for this line is y equals 1.16x plus 19.07. In a couple of days, we're going to use Desmos to do lines of best fit. And it's really, really neat how Desmos can calculate that for us. In part D, it says interpret the slope of this line by filling in the blanks. In April, the high temperature increases or decreases by how many degrees for every blank degree increase in low temperature. Okay, so if you look at our line, right, our line is increasing. Okay, so we know it's going to be going up because the slope is positive. Okay, so it is increasing by 1.16 degrees for every high degree increase in low temperature. That might sound a little confusing, but all we're doing here is we're figuring out the slope. So basically what's happening is every time that we take a low temperature x, okay, and we increase it, we're increasing it by 1.16 to get the high temperature. That's all that's happening. Part E, interpret the y-intercept by filling in the blanks. In April, if the low temperature is blank degrees, the high temperature is predicted to be blank degrees Fahrenheit. So what this is saying is we know the y-intercept has 0 for the x value and some number for the y value. In this case, our y-intercept is 19.07. So that coordinate point would be 0, 19.07. So when the low temperature is 0, because low temperature is x, the high temperature is y at 19.07. Use your line of best fit to estimate the high temp, given that the low temperature was 42 degrees. So we're going to find 42, go up to our graph, and it looks like about 62, or about 66, 67. Okay, you can put 66 or 67 there. Use your line of best fit to estimate the low temp, given that the high temp was 54. So if you go to high temp, 54 would be here. So right there for the low temperature, it would be 28 degrees. Okay, then it says use the equation for your line of best fit to estimate the high temperature given that the low temperature was 16 degrees. So the key here is that we know the low temperature. And if you go back, low temp is X. So we're going to plug in 16 for X. If you wanted to do this on Desmos, you could, but you can also use your calculator to help you. So if I plug that into my calculator, I get 37.63 degrees. Okay, so that is the high temperature when the low temperature was 16 degrees. Letter I, use the equation for your line of best fit to estimate the low temperature given that the high temperature was 80 degrees. So now you're given the high temperature, which is Y. So I'm going to take my equation, and for Y, I'm plugging in 80. So we're going to solve for X. Our first step in solving for X is to subtract the 19.07. Again, you can use your calculator to help you out here. Or Desmos, obviously. Divide by 1.6. I'm sorry, 1.16. And we'll say 52.5 degrees. Would you characterize the relationship between the low and high temperature as positive or negative? So if you go back to our graph, since the graph is increasing, that would be positive. Okay, and the next question is it going to be a strong correlation or a weak correlation? Here we would say pretty strong because the dots are close to it. So our reasoning is that increasing data and dots are close together. All right, the R value is 0.9478. Okay, does that match what we just said in J? Absolutely it does. 0.94 is really strong, okay, and it's positive. So yes, it does. All right, example 2. We have some data. We're not going to plot the scatter plot this time, but you are given the line of best fit equation. So you're going to use that in part A to predict the house value of a person whose most expensive car costs $19,500. So we look to the table. Do we see $19,500? Absolutely, it's right here. Okay, so if their car cost is $19,500, then $255,000 is the cost of their house. We didn't have to use the equation for that because it was in our table. Part B, was the prediction in A an overestimate or underestimate? So here's what we need to do. Okay, I was incorrect. In this question, let's go ahead and use our actual equation. Let's plug it in. And then we're going to see if it is an overestimate or underestimate. Okay, so if we plug it into the equation, we get 267,766. But in our table, we have 255,000. So we would call this an overestimate. An overestimate because the number is over what the actual value was in the table. In part C, our R value is determined to be 0.97. That's very strong, okay, and it's positive. Okay, But let's put this in context of the problem. So think about, we're talking about car cost and house value. So ideally, if somebody pays quite a bit for their car, you're going to assume that their house value is probably pretty high. They probably are pretty wealthy. If for some reason their car cost is really low and they have a car that's kind of a beater type car, is what we would say, maybe their house isn't going to be as nice. Obviously, there's some room for error here, but for the most part, that would be true. So in part C, we would say the nicer, okay, or you could say the more expensive the car, the nicer the house. All right, part D. So we're going to focus on our equation now. The value of a person's house, does it increase or decrease? So first of all, take a look at the slope. The slope is positive. That tells us it's increasing. Okay, so the value of a person's house increases by $12 for every $1 that their car costs. So every $12 for every $1 of car costs. So their house is going to go up $12 every time their car value goes up $1. Okay, part E, interpret the y-intercept of the equation by filling in the blanks. Okay, if a person's car costs $0, right, because we're talking about a y-intercept. So our y-intercept is 0, 3, 3, 7, 66. And I got that from up here, our y-intercept. So for when somebody's car is $0, their house cost starts here. And we kind of talk about why the y value being an initial value. Our initial value here is the 33,766. And then from there, it will go up $12 every time our car goes up $1. All right, example 3. Miss Musto opened a new coffee shop. She recorded the number of customers she served between opening and noon for the first 20 days. And her data, you can see there in the graph. Her results are shown on the graph. Let's see if we can find the line of best fit. So let's draw a decent line of best fit. Okay, somewhere there, maybe. Maybe I could have gone a little bit higher. Okay. So what I want us to do now is look at these guys, okay, and see if we can pick out which one is going to fit best. And I'm going to go ahead and use the slope to help me out here. So let's say I started at 20, and I went up 1 over 1. We wouldn't say that that's going to be the line of best fit. So I'm going to go ahead and cross out D, because that would be y-intercept of 20, slope of 1. But if I go, let's say I go to 30, and I go up 3 over 1. Oh, that's definitely not going to work. Cross that one out. Okay, what about 20 up 2 over 1? Yep, doesn't look like it to me. That one's pretty off. All right, let's start at 10 and go up 3 over 1. Oh, no, that's not good either. Okay, so let's go back. This is to show you not all of these questions are going to be perfect. You have to pick the one that you think is best. So if you look at our data, okay, we would assume that the y value, or the y-intercept, is probably about 20. Probably about 20. So let's go ahead and cross off A and C. And then I would say, if we pick D, that would be our best case scenario. It's closer to the data than the rest of the line. Okay, let's go ahead and draw our line of best fit. Okay, let's draw the one that we think would work best. Okay, it says use the line of best fit to predict the number of customers on day 25. Ooh, let's extend that line. Looks like to me it would be 80 customers. If you look at 25 here, and then where it crosses the 80, we're good to go. All right, part D. Use the equation you circled to estimate the number of customers on day 25. 25 for the day, which is x, plus 20 for our y-intercept, and that would give us 45. Okay, is it close to what we predicted in part C? No, it's actually a little under. Okay, we would call this an underestimate. Okay, go ahead and work on your practice. You can find the answers to this posted in your on Canvas in the day 2 or the lesson 2 under unit 6. You can find the key for the practice.